We saw that the linearity of the wave equation points that if two waves satisfy the linear wave equation, a linear superposition of them also satisfies the linear wave equation. Let's study some of the properties of wave interference. If we have a string attached by its two ends and make it oscillate from one end, we will be generating waves on the string. If on top of that oscillation we add a different vibration to that end of the string, with one different oscillatory motion, the particles of the string will be under the effect of both actions, and their behavior will be that of the sum of both vibrations. Depending on the relative frequency between both vibrations, we will have that in some points of the string the interference will be constructive, and in some others it will be destructive. We could even add a second vibration at the other end of the string. The resultant wave is the sum of both waves. So we can take the equation of each wave and add them algebraically. Depending on the relative frequency, we can get as a result a new sinusoidal wave or something much more complex. For example, if we add two waves of the same amplitude and frequency but different phase, using this trigonometric identity, which can be rearranged as so. This is a new sinusoidal wave that has an initial phase, half of that between both initial waves, and whose amplitude is changed by this factor. Depending on the phase shift between both waves, the amplitude will be greater or smaller. Both waves can add up constructively or subtract destructively. There is a particularly interesting case when one wave propagates one way and the other propagates in the opposite direction. But we will see that in the next lesson. May science be with you.